Alright, let's go over example 6. In example 6, we have two rational functions. In f of x equals 3x plus 1 over x squared minus 25, if we take a look at the denominator, x squared minus 25 is a special form of quadratic expression called the difference of the two squares. So, rewriting x squared minus 25 into x raised to the second power inside of parentheses minus 5 raised to the second power, I get to factor the denominator out to be the product of x minus 5 and x plus 5, and of course keeping the numerator the same. Same thing can be said for the denominator of g of x, because x squared minus 9 is also a special form of the difference of two squares. So with x inside of parentheses raised to the second power and rewriting 9 into 3 and this 3 is raised to the second power, I get to factor this denominator out to be the product of x minus 3 times x plus 3, and of course the numerator can be factored out to the product of 2 and 2x minus 1. So in any rational function, of course, to find the domain, we take the denominator and set it not equal to 0. So in this case, with the word that I did before, I'm going to take x minus 5, set it not equal to 0, and separately x plus 5 not equal to 0. Solving for x in each case, we know that x cannot be equal to positive 5, and x cannot be equal to negative 5. Same thing can be done for here. X minus 3 cannot be equal to 0, comma x plus 3 cannot be equal to 0. Solving for x, we know that x cannot be equal to 3, and x cannot be equal to negative 3. So these are the restrictions of the domain of f, and these are the restrictions of the domain of g. So I'm going to box it just in case. Well, not just in case, but I'm going to go back to it later. Now, what about the quotient f of x over g of x? Well, that's going to be this over this. All divided by 2 times 2x minus 1 all over x minus 3 times x plus 3. And let me erase this. So at this steps, what we want to do is that we want to make sure that the denominator cannot be equal to 0. So let's see, in this case, we know that x cannot be equal to negative 5. I mean positive 5, x cannot be equal to negative 5, x cannot be positive 3 and negative 3. So of course I'm not going to go ahead and write a work for the restriction of these steps. I'm just going to go ahead and list it out. But what I'm going to do is that I'm going to set this entire denominator and set it not equal to 0, because assuming that this little denominator here is not 0, but if the numerator here is 0, then the whole denominator is going to be 0, and that's going to make it, that's going to make the whole thing undefined. And if it's undefined, we cannot solve the problem. So I'm going to take this whole thing, 2 times 2x minus 1 divided by x minus 3 times x plus 3 not equal 0. Multiplying both sides by x minus 3 times x plus 3. Let's see. Hopefully I got room to squeeze it in somewhere right here. And I'm going to squeeze it in here. X minus 3, x plus 3, and over here as well. Well, we know that this will cancel this out. And 0 multiply anything on the right is going to be 0. So we're left with just 2 times 2x minus 1 not equals 0. Divide both sides by 2. I got 2x minus 1 not equals 0. Add 1 to both sides. I got 2x equals 1. Divide both sides by 2 to get x by itself. Yeah, x cannot be equals to 1/2. So this is another restriction from this steps, in addition to these ones right here. Let's simplify a little more. So we have a fraction divided by another fraction. So we have to change this division into multiplication by keeping the numerator fraction the same, which is 3x plus 1 divided by x minus 5 times x plus 5. Change it to multiplication by the reciprocal of the denominator fraction. So instead of, just take the denominator, move it to the numerator, and the numerator move down to the denominator. So we're going to have the product of x minus 3 and x plus 3 all over 2 times 2x minus 1. And of course, we can tell right here that at this step, x cannot be equal to positive 5 and negative 5. And of course, based on the work that we did right here on the right, we know that x is also not 1/2. X is not allowed to be 1/2 either. So at this step, the restrictions are x cannot be equal to positive 5 and negative 5 and 1/2. And let's just put everything together. So we are going to have, let's see, 3x plus 1 all over x squared minus 25 times x squared minus 9 over 4x minus 2. And let's see. And of course, restriction right here are the same as above, because this is just the unfactor form of the step above. So x cannot be equal to plus or minus 5, comma 1/2. Let's FOIL everything. Foiling everything, 3x times x squared, it's just going to be 3x cubed. 3x times negative 9 is going to be negative 27x. 1 times x squared is just going to be plus x squared. 1 times negative 9 is going to be minus 9. X squared times 4x is going to be 4x cubed. X squared times negative 2 is going to be negative 2x squared. Yeah. Negative 25 times 4x is going to be negative 100x. Negative 25 times negative 2 is going to be plus 50. And I'm not going to, and for the restriction right here, I don't think we're going to have any, because, if we were to factor it out by group, so it'll be the same. So yeah, I'm not going to go ahead and do the work because you guys know how to do it. But anyway, what's this one? Combining like terms. Well, we cannot combine like terms right here, so numerator stay the same. So 3x cubed plus x squared minus 27x minus 9 all over 4x cubed minus 2x squared minus 100x plus 50.